We're going to be taking a look at lesson 6.6 in this particular video, once I get everything set up. This 6.6 is Optimization Problems Part 3, where we take a look at actually finding the solution straight through to the end of an optimization problem. And the title of this one is Linear Programming. The objective is just to be sure that you actually know how to find a solution to an optimization problem. Now, last class we learned that our solutions to any optimization problem were usually found at one of the vertices of the feasible region. And today we're going to be taking a look at that, going straight through to the end. And when we talk about solving optimization problems, we are using something called linear programming. And basically, there's nothing new in what we're doing. We're simply taking the skills that you've developed so far and bringing them to a conclusion so you actually find an answer to the problems. So we're going to be taking a look at the following example. So take a moment to read it, pause the video, and make sure you're familiar with what's taking place. And we're going to be doing step number 1, defining the variables that affect the quantity to be optimized and stating its restrictions. So as you have learned as we've been working through these things, that when you're looking for the quantity that needs to be optimized, you look at the last sentence. How many of each should they make per day to earn the most money? So it looks like we're being asked to optimize basically the profit or the money that they're earning. And if we look back, we realize that that's going to depend on how many copper bracelets they sell and how many necklaces they sell. So these will be our variables. And as with many of our questions, it makes the most sense that these values, x and y, are whole numbers. Step number 2, identify the quantity to be optimized, which we've already done. So profit or revenue, you might call it, is to be optimized. From the last sentence, we saw that. The next step is to take that fact that you want to optimize the profit and create the objective function. So create the equation that will actually help you determine what the profit will be. Well, if you look at it, it's $5 for every bracelet, so that's 5x, and $7 for every necklace, which is 7y, and that will give you your profit. So here is your objective function. This is the mathematical equation that we're aiming to find the greatest amount for. The next thing we need to do is to go back into the text of the question and find all of the constraints. Now we've got a few. This one. We have a couple of things actually happening here. You've got them telling you about time it takes to cut these things and time it takes to polish. So you've got two scenarios going on, cutting time and polishing time. So when you set up your constraints, you need to look at setting up a constraint that involves the cutting time and then one that involves the polishing time. And so when we work on that, you'll realize that the cutting time for the bracelet is 15, so that's 15x, and the cutting time for the necklace is 15, so that's where 15y comes from. And then they tell you that there are a maximum of 225 minutes of cutting time, so less than or equal to 225. Then we look at the polishing time. So 10 minutes for the bracelet, so that's 10x, 20 minutes for the necklace, so that's 20y, and it has to be less than or equal to 200. So here are your two constraints. These will be the things that we need to draw a graph for. Now, you will remember that I've been recommending to you that you look for the x and y intercepts for drawing these kinds of things. If I make the x a 0 in this one, then y is 15. If I make y a 0, then x is 15. So those are my two intercepts. Here, when I make x a 0, that means y comes to be a 10. So my y-intercept is 10. And when I make when I make y a 0, then x will be a 20. And that shows me my x-intercept. So in terms of doing that, I'm going to be creating a graph that looks like this. One that has intercepts at 15 and 15, the red one, and I'm showing underneath it. And then one that has an intercept for the y-intercept at 10 and one at 20. And again, I'm going to be doing underneath. So what I've created is the feasible region of this particular function. This is where my answers will be. Now, what we explored last time and what we're looking at more specifically now is that we know our answers to the question of finding the maximum profit will be at these vertices. And so the next thing we need to do is actually name our vertices. Now, it's not too hard to name the first ones. Here's 0, 0. This guy is 0, 10. This one in the corner is 15, 0. But the one that's going to take a little bit of time is the intersection of these two lines. What actually is the intersection? So in order to find that, you have to solve a system of linear equations. So you take your two functions and I've chosen to use elimination. So I multiply the top one by 2 and multiply the bottom one by 3. Then I subtracted them. 30 minus 30 here gets rid of the x's. And then 30 minus 60 is negative 30. 450 minus 600 is negative 150. And when I'm finished, y turns out to be a 5. And I know by substituting it back into one of these equations that if the y is a 5, then x turns out to be 10. So my missing point is 10, 5. This point right here is 10 and 5. So now I know all 4 vertices of my feasible solution area. And so the next thing I want to do is take these and substitute them into my objective function and see how much they're actually worth. 0, 0, 0, 10, and so on. So once I do that, I realize that the first one, if I put zeros in both, it turns out to be 0. If I put 0, 10 in, this will be a 0 and this is 10, then I get 70. If I get 15, 0, 5 times 15 is 75. And then lastly, the one that I found, the last part, which is 10 and 5, turns out to be 85. And it turns out then that this is the one that gives me the greatest profit. So I finish by saying that the greatest profit will be achieved when they sell 10 copper bracelets and 5 necklaces. So just a couple of things as you look at these types of questions. Whenever you get your solution, it's always a good idea to make sure that your solution is within the constraints of the problem situation. In our case, it's pretty clear. We've been careful about our graphing and so on. We're fine. But every once in a while, you may find as you go through some of the questions that it becomes something that does not exist in the original constraints. So be careful of that. And always give a final concluding sentence that demonstrates you know what the solution actually means in the context of the problem. Don't forget to do that. It's a very crucial part. Okay, so there you have it. That's solving optimization problems. Do make sure that you take time to do the homework. Now, the homework for the first day was questions 1 to 4. And for the second day, it's number 5 and 11 to 15. There's a fair amount of homework here because there are fair amounts of styles and scenarios that you can run into when you're setting up these models. And so I wanted to make sure that you had seen everything before you tried to actually work on an assessment for it. So make sure you do each part and that you bring your questions to class. Good luck, everybody.